All right. Now, let's listen up. We'll be looking at transient kinetics. And to understand transient kinetics very well, we'll look at the two words there, transient and kinetics. So transient kinetics under enzymology, enzymes. Now, when they say something is transient, what does it mean? It's changing, right? It's not stable, is it not? When they say something is transient, it's changing from one state to another. It's changing. It's not stable. That's the meaning of transient. Now, when we talk about kinetics or enzyme kinetics, we are looking at the behavior of an enzyme. So we are looking at how enzyme and substrate combines to form enzyme substrate complex and product. So we are looking at the behavior of that enzyme, the rate of the reaction. We are studying the rate of reaction. That is kinetics. So if you are studying the rate of reaction of enzymes, what you are studying is enzyme what? Kinetics. Do you get that? Now, we've seen that transient means something that is not steady, something that is not stable. And we've seen that kinetics, you are studying the rate of the reaction. Now, transient kinetics is the study of the behavior of an enzyme when the steady state is not yet reached. Do you understand? Transient means something that is changing, right? Something that is not steady, something that is not stable. Then kinetics is the study of the rate of the reaction, right? Rate of reaction. Now, transient kinetics is the study of the behavior of enzyme reaction when the steady state is not yet reached, have not been achieved, when the reaction is still going on, when the reaction is not steady yet. That is transient kinetics. So if you are asked to define transient kinetics, just tell them transient kinetics is the study of the behavior of an enzyme when what? Read what you have there in your notes. The study of the behavior of an enzyme during the period before the steady state is reached, right? So you are studying the enzyme when the now this, let's look at this. We know that if we have an enzyme E and substrate binds, what we are going to have is what? Enzyme substrate complex, right? Then catalysis will take place and we'll have enzyme plus product giving off. Is it not? Now, if we have something like this, enzyme plus substrate giving us enzyme substrate complex, you agree with me that there will be a period as you put the enzyme and the substrate together, reaction will be ongoing, right? The reaction will be ongoing. As this one binds to this, reaction will be ongoing. So you see that the concentration of the enzyme will be changing. The concentration of the substrate will be changing continuously until equilibrium is established. So that study of the behavior of the enzyme as the concentration of the substrate and the concentration of the enzymes are changing is called the transient kinetics. So the study of the behavior of an enzyme when the concentration of the enzyme and the concentration of the substrates are changing is called transient kinetics. Now you ask, if you have an enzyme, let's say you have hexokinase. What reaction is hexokinase catalyzing? Conversion of what to what? Glucose to what? Glucose to glucosylceosate. That's the first step in glycolytic pathway. What is the substrate of this reaction? What is the substrate of this reaction? What is the enzyme catalyzing? The conversion of glucose to glucosylceosate, right? Glucose is the substrate here now. Glucose is the substrate. Hexokinase is the enzyme. And glucosylceosate is the product of this reaction. So, if this substrate binds to this enzyme and catalysis starts to take place, you discover that if you started with, let's say, 10 molar of glucose and the enzyme, you started with 5 molar. That is the concentration. As you put the enzyme and the substrate together and catalysis starts, you discover that the concentration of this substrate and the concentration of the enzyme will be changing continuously. So you studying the behavior of the enzyme of this reaction when the concentration of the substrate and the concentration of the enzyme is changing, that is what we call transient kinetics. At this point, the final product has not yet been formed. The concentration of the enzyme and the substrate, they are just changing. That is enzyme kinetics. All right, so in transient kinetics, how do we study the behavior of an enzyme when the reaction is not steady? How do we do that? We have the rapid mixing techniques that we use to study this reaction. Now, the rapid mixing, when they say rapid mixing, you just mix the enzyme and the substrate together rapidly. It's a fast reaction. It's a fast reaction. So you just put the substrate, glucose in this case, and the enzyme, hexokinase in this case. As you put them together, you know reaction will take place. It's just like you put goat and yam, and you expect the goat to be looking at the yam without eating. It's not possible. If you put the enzyme and the substrate together, of course, catalysis will take place rapidly. Then as the reaction is taking place now, you will now measure the rate of the reaction. That is the rapid mixing techniques. But where you expect an exam is the two methods under the rapid mixing techniques. And the two methods under the rapid mixing techniques are what and what? Continuous flow method and what? Stop flow method. Please, you are free to say continuous flow method or technique, anyone. You are also free to say stop flow method or stop flow technique. But we know that these two methods fall under rapid mixing techniques, right? Rapid mixing meaning we are allowing the enzyme and the substrate to mix together rapidly. Good. Now, the continuous flow technique. Now look at this. You've all seen syringes before, right? Syringe, that thing they used to use and give injection. Now, this one here is one syringe. One of that thing used to hold like this. This is one. Look at it very well. This is another syringe also. In one of the syringe, you add enzyme. You put enzyme in it. And in the other one, you put the substrate. So let's say the enzyme is hexokinase. You put it in the syringe here. Here, you put the substrate in another one, say glucose. Then you push them at the same time. So if you push them into a chamber, into a tube, a pipe, we call this a reaction chamber. So if you push this plunger now, if you push this thing, push this one, you agree with me that the enzyme, a liquid now will move from here, right? Substrate will move, right? Until they will mix here. Is it not? Because the enzyme is coming here, the substrate is coming here. You discover that the enzyme and the substrate will meet at this point. And once they meet here, remember, once the enzyme and the substrate meet, the reaction will start to take place, right? Now, as they are flowing through this place, reaction is taking place. The concentration of the enzyme is changing. The concentration of the substrate is changing. So that is why we say transient. Now, as this is the mixture is flowing through this place, we can measure the concentration of either the substrate and the enzyme at any point. So we have observation chambers that we use to measure their concentration. Now, in continuous flow, you will keep on pumping enzyme and substrate. That's why it's called continuous flow. Enzyme and substrate will be pumped continuously, and you can measure. This observation chamber can be placed at different points. That is how you measure that. So in continuous flow, you are pumping in reagents continuously. This continuous flow, if you look at it, since the reaction is just like it's just like water is just flowing through a pipe continuously, you agree with me that you need large amount of reagents, right? Because we will be pumping enzyme and substrate continuously. So the reaction will need large amount of reagents. Because if we have small amount of enzyme and small amount of substrate, we cannot keep on pumping. Is it not? It cannot flow continuously. So what do you think? Is it a good method or a wasteful method? It's a wasteful method, right? Because it requires large amount of reagents. So because this continuous flow requires large amount of reagents, they modified the continuous flow method to get the stop flow method. The continuous flow method was developed in 1923. But after some time, they were using it until 1940s. They modified this same method to have the stopped flow. Now remember, continuous flow, the reagents will keep on flowing, right? You keep on pumping reagents. Why stopped flow? As you put the reagents one time, you stop. You measure at one point. Now let me explain. In the stop flow, still the same setup. Here, this is the enzyme. This is the substrate. You push the enzyme and the substrate, you know here they will also mix here. And as they mix, your observation chamber, you place it very close to that place where they mix, because you know the reagent and the substrate is very small. So you place the observation chamber at one point here, and you can measure at one point. The difference between this continuous flow and stopped flow is, in continuous flow, you keep on pumping reagents, substrate and enzyme, you keep on putting it, and it will just be flowing. This pipe is long, it will just be flowing, and at different points, you can be measuring the rate of the reaction at different points. But in stopped flow, you just pump reagents once, put the observation chamber close to where they will mix, knowing that the enzyme and substrate is not much. So you put the observation chamber close to this point where they will mix, and you measure it once. You measure it at that point. So you don't have a long tube where reagents are flowing. You don't have that. So you see that this one is more economical than this one. They are doing the same thing, but this one is more economical. Now the three questions you can see from this topic. Define transient kinetics. And we say transient kinetics is the what? The study of the behavior of an enzyme before what? Before the steady state is reached. Or it said the study of the behavior of the enzyme during the period before the steady state is reached. So what we are saying is that you are studying an enzyme catalyzed reaction when it has not gotten to the final stage, when it's not stable yet, unstable. The rate of the concentration of enzyme, concentration of products, of substrate, they are changing continuously. The second question you can be asked is to discuss these two methods. And to discuss these two methods, all you have to do, the continuous flow requires continuous input of enzyme and substrate, right? And as they mix, they will pass through a long tube called reaction chamber. Then you have observation chambers everywhere at different points that you can use to measure the rate of the reaction. Why stop flow is just a modification of the continuous flow, and it is modified in such a way that you just add the enzyme and substrate and place the observation chamber close to this point where they mix, so that you can measure at that point. So it does not involve a long tube where the reagents will be flowing and you'll be measuring at different points. Now, let me ask a question. What do you think is a disadvantage of this method? It requires what? Large amounts of reagents, right? And so it is what? Wasteful. It is expensive too, because you have to buy large amount of this stuff. So it is wasteful, it is expensive, it requires large amounts of reagents for this. But in this case, that becomes an advantage, right? Because it requires small amount of this. Now, that's why you're coming to. What is the advantage of this continuous flow method? It allows you to study, remember, it allows you to study the rate of the reaction at a what? Steady state, right? Just look at a pipe with water flowing through it. There is how water will flow through a pipe and you don't even notice that the water is flowing. I don't know if you have noticed something like that. There's how water will be flowing through a pipe and you don't even notice that water is flowing. You think it's just like that. It's looking steady, but it's actually moving. That's what is happening here. The reaction, the concentration of the enzyme and substrate, they are changing. So this reaction is not stable yet. But because it's continuously flowing, you can study the rate of the reaction at steady state, though it's not steady. But you can study the rate of the reaction at steady state. But yeah, you cannot use it to study reactions at steady state. Do we get that? I need one clear difference between one disadvantage of this one, of this stop flow. There's, if you really understand, there is one disadvantage you tell me about stop flow method. Yes. You said? Okay, you cannot use it to measure the reaction at different points, right? I said that you just place the observation chamber close to this point where they meet. So you just, so it's just once. You cannot place it at different points. That's one. I need another one. But what of, you know, there are some reactions that are very slow. That if you mix them together, if you mix the enzyme and the substrate together, they are very slow. So that they can even get here said, I know slow like snail moving. Enzyme and the substrate is still trying to adapt to the active site and no reaction have even taken place. And as they are moving, the substrate is trying to fit into the active site, reaction have not really taken place and they don't reach observation chamber. So you see that you cannot use it. You cannot use this one to study reactions that occur in a slow rate, right? A slow pace. But this one you can use it to study something like that because as the tube is long now, do you get? But generally, we use them to study rapid reaction, fast reactions.